Welcome, everyone, to another Chemistry 1 lesson with Mr. Swank. Guys, it's Monday, May 11th, and we're moving on to a new chapter. I know last week the sig fig stuff was a little tricky, a little hard to deal with, but that's okay. It's just a basic little concept that's going to keep coming back, but it's not a huge deal. It's just best that you be, introduced to it and whatnot. But starting this is going to be the last section of chemistry, this chapter, and this is going to go through the rest of the year, okay? So I hope you all are ready. So let's start the day, as we always do, with a joke. I had a boomerang joke, but I can't think of it. It might come back to me. All I remember is that it went over people's heads. Did that one go over your head? I hope you got it. So our objective today is we're going to define moles as a unit of measurement in chemistry. And if you remember, back when we talked about metric units, I said that amount was measured in moles in the metric system. We're going to talk about that today and introduce what that really means. So we're starting Chapter 10, Chemical Quantities. So let's talk about quantities for a second. When you're out in the real world, there's a lot of different ways that we measure quantities. Now, we could just count things, or we have a bunch of different words to describe an amount of something. For example, we have the word dozen, which means 12 of something. Okay? Well, it's a baker's dozen. That's not the same thing. No. Straight up dozen is 12, okay? We know a pair is 2, like a pair of shoes, a pair of gloves, it's always 2. A gross is 144 of something. For example, restaurants and whatnot will order eggs by the gross because they need a lot of eggs. That's 144 eggs. And paper, such as printer paper or lined notebook paper, when it comes in stacks, it's called a ream. And a ream is 500 sheets. Now, why do we have these words? Because it's easy and convenient. I mean, when you go out and you buy donuts or eggs for yourself, things like that, a dozen is the best way to do it because it's, a decent number. You get a dozen donuts to bring to the office to share with people. A dozen eggs will last you for a week or so. Restaurants order a gross of eggs because it's 144 and they're going to go through a lot. And paper, a ream of paper, it's nice to get 500 sheets because depending on how much you're printing, you might go through stuff a lot. It's easier just to have a set amount that we work with in these things. And the same is true in chemistry. We know atoms make up substances. It's been a basis of a lot of stuff that we've talked about here. But is it efficient to talk about how many atoms are in a large amount of a substance? For example, if I want to talk about the number of atoms in this paintbrush, I'm not going to count them all. Atoms are incredibly tiny. And if you remember back to chapter 4, I believe, I characterized the size of an atom as being there were 2.4 times 10 to the 21st copper atoms in a penny. 2.4 times 10 to the 21st. In the last chapter, we talked about scientific notation. See if you can figure out how many that is. It's a lot. So it's not efficient to talk about how many atoms are in really any substance that we can manipulate, which is why we have a mole. It's the amount we use in chemistry. It is the metric unit of amount. And it's the same concept as dozen, gross, or pair. It is a word that represents a set amount of something. Remember, dozen is 12, gross is 144, pair is 2, ream was 500. So what does a mole represent? A mole is 602 hextillion of something. That's a lot. That is a lot of zeros there. Now, of course, you're not going to see it written like that. Why? Because it would get ridiculous to write all those zeros. I had to count that multiple times just to make sure I got it typed up right. The truth is, we refer to it as 6.02 times 10 to the 23rd because scientific notation makes the number smaller, easier to write. Now, that number is known as Avogadro's number. Okay? So if you hear anybody talk about Avogadro's number, they're talking about 6.02 times 10 to the 23rd. That is the number of things in a mole. Meaning, if you had 602 hextillion or 6.02 times 10 to the 23rd ducks, you would have a mole of ducks. Just like if you had 12 ducks, you have a dozen ducks. 144 ducks, you have a gross of ducks. So on and so forth. A mole works the same way as those. It is 602 000 000 000 000 000 000 000 000, or more easily stated, 6.02 times 10 to the 23rd. Now, it's called Avogadro. It's called Avogadro's number because it's named after Amadeo Avogadro. He clarified the difference between atoms and molecules way back before we knew much about this. He didn't calculate the above number. He had nothing to do with it. It's just named to honor his accomplishments, okay? Now on to the more pressing stuff. In chemistry, we specifically say that 1 mole is equal to 6.02 times 10 to the 23rd representative particles, meaning we can refer to the number of particles in an object, like my paintbrush, in terms of moles instead of how many individual particles there are. Now, what are representative particles? It is the smallest representative piece of a substance. In other words, atoms, molecules, and formula units. They are the smallest piece of the different substances we can have. Representative particles for pure elements are typically atoms because we know the smallest piece of an element is an atom. Now, notice it says typically, because it wouldn't be chemistry or science in general if there wasn't an exception. But you know what? You guys know the exception. There are 7 elements that are the exception. Have you figured it out? Do you know what it is? Hofbrinkel! That's the exception. Because remember, all of those are diatomics, meaning they are not single atoms. They are 2 atoms bonded together, meaning their smallest piece is actually a molecule. The representative particles for covalent compounds are molecules, and the representative particles for ionic compounds are formula units. We've talked about that in the past. So what does that mean? That means if I have 1 mole of aluminum, how many atoms are in there? Well, we look back up. Aluminum's an element. Atoms are its representative particles. If I have 1 mole is that many particles. 6.02 times 10 to the 23rd atoms of aluminum. How many molecules in 1 mole of carbon tetrachloride? Well, carbon tetrachloride is a covalent compound. There's a prefix there. Remember that. So how many molecules in 1 mole? Molecule is a representative particle. 1 mole, well, 1 mole equals 6.02 times 10 to the 23rd molecules. And lastly, how many formula units in 1 mole of sodium chloride? Sodium chloride is an ionic compound. Formula units are a representative particle. 1 mole. 1 mole equals 6.02 times 10 to the 23rd representative particles. So there you go. What you need to keep in mind is that mole is just another word like dozen or gross or pair or anything else that means a number. But unlike dozen, which is only 12, or pair, which is only 2, a mole is 6.02 times 10 to the 23rd. And in chemistry, it is specifically the particles that make up a substance. So for any given substance, we can talk about how many particles are in terms of moles rather than officially counting how many there are, because there's so many because of how small these particles are. Okay? Now going forward, we are going to be doing some math with this. So keep that in mind. Okay? But thank you everybody for joining me. I hope you enjoyed it. I hope you're having a good start to your week. And you know what? I'll catch you all tomorrow.